Hi everyone, my name is Prerna Singh. Presently, I'm working as a data scientist in Unity Veda Digital. Today, I'll be discussing how I have been improving machine learning model performance in various areas or application by adopting various data-centric aspects of AI. So as we all know, machine learning isn't always been about data, but data science team have only recently moved their focus to the data. And of course, great thanks to the introduction of strong push button models. AI and ML researchers continuously developing algorithms in order to improve the performance of AI system. But model-centric approaches are limited in the absence of quality. Performance of these state-of-art methods can be greatly improved by improving the data quality. Certainly, data-centric approach is relatively a new term. Industry started understanding need of quality over quantity. The time is fading when data science team used to say more data. Now things are shifting towards quality data or a good data. Now data science teams, researchers, industry considering data itself as a product. Data is no more static, it is dynamic. Every fraction of second we are generating so much of data. Data science teams improving model performance by improving data quality. The most crucial aspect of data-centric modeling, which I personally advocate all the time, how well we transfer our expertise or SME knowledge to improve the data quality, and which then help us to improve the model performance or model accuracy. It is definitely highly iterative process in the entire life cycle of data-driven AI product. So, data-centric modeling aspects. So let's see what kind of data-centric aspects researcher, data science teams, ML folks are adopting based on their use case or based uh, on the problem in hand. I have stated pretty much a good number of data-centric modeling aspects. There are various aspects researchers or data science teams are working or developing based on their needs. Some of the aspects pretty much recommended in almost all machine learning problem. Few might be very specific to the problem you are solving. So here I have mentioned from big data to good data. Basically, big data to good data is a quality data. Data collection, data augmentation, feature engineering, synthetic data, and so on. So among all these which I have stated, it is not necessary that you will be using all. It is highly depend on the problem. So there is one aspect which it is gaining importance in various discipline, which is big data to a good data. So big data to good data, in various applications, people are moving in this direction. The reason is in spite of having too much of data, still data science team and ML researcher unable to get a desired outcome or desired model performance, which can potentially fulfill business needs. So before I discuss few data-centric aspects which I have used in my previous research and some aspects which I have been using in my present organization with some application and use case, I would like to show and discuss how a data-driven modeling lifecycle look like. So here we are seeing a major components of any successful AI product or application. Here we have a data, we have a model, and then MLOps is the machine learning in operation. So these three components are highly linked together, and definitely for production level machine learning application highly depend on these three components. If we focus on the center part, which is a model is nothing, it's just a piece of code. It's a piece of code, piece of algorithm, which has a set of parameters. So once the data is ready, we are happy with the data, we are happy with the data quality, we have all the required features. It is ready to feed to the model, and then we train the model, and then we optimize the parameters, and then retrain the model. Then again, we just back and forth in this entire loop. And once we are happy with this, the model we have developed with a given data, we place in the production. There are some components which are basically applies to any application, like data quality check. Of course, when data is coming from primary to secondary database, this is the first level of data quality check we perform. Then if we wanted to collect more data, then we have to again be very careful and check again, perform the data quality checks. And once we have a data and data science team start working, We have to perform a data analysis, data understanding, data wrangling. We have to prepare a data, and if required, we have to create a lot of features by ourselves. And then we have to see, is data is dynamic or data is static? What is the distribution of the data? Is data showing any trend? Is data random? And what is the frequency of changing our data? For some specific case, we might need to create a synthetic data, or we might need to collect the data fully based on transferring SME expertise. So these are the two cases which highly depend on the problem in hand. If you have a if you are working with a machine learning problem, you have a data but not enough data, or probably you wanted to create a data which is based on transferring a subject matter expertise. So in that scenario, we create a synthetic data where it is possible. Again, it might not be possible to create for all the applications. Yeah, but if you're creating or collecting a data based on transferring SME knowledge because we are solving a very specific and targeted business problem, yes, then in that situation, transferring SME expertise and then collecting and creating a data would be a good solution. Then finally, when we are ready, data is prepared, analyzed, and understood nicely, then finally we feed our data into the models. And then again, once we have done the baseline model, then we go for hyperparameter optimize. We just change the parameters and again retrain the model. If you're happy, then only we place the model in production. Once the model has been placed in the production, in order to maintain the model performance, we have, because model is highly depend on data, because data is the most important product of the model. We have to monitor our model if in case later on the distribution of data changes or relationship between independent or dependent variable changes. So in order to keep our eye on data, because now the model is in production and the data is in production. So if there is any shift happens in the data, or if any relationship between the features and target changes, so we should be immediately able to capture. So before the model performance starts degrading, it will alert us so that we can again retrain our model. So before we retrain our model, we should be very careful. We have to check data again properly rather than blindly retraining a model and placing in the production. So whatever we are discussing today around data-centric modeling aspects, so the whole the theory and the how the people are developing different concepts, how they are approaching for different application, how they are improving their qualities by developing lot of data level solution first, then the model level solution. So you will find there are a pretty much handful of research papers and how industries are approaching in direction I have found, and I have compiled in this paper a systematic review of data-centric approaches in artificial intelligence and machine learning. So the detail of all the discussion we are doing today you will find in this paper. So now I'll be showing a few application and couple of aspects we have adopted in my previous research in the area of medical image analysis. We were developing segmentation and classification algorithm for post-process ultrasound images. So based on problem in hand and after a lot of discussion with a radiologist, we have gathered pretty much good amount of data. Also collected from variety of devices. Again, it is very important if you're working with the medical imaging, all the data should not be just collected from the one single device. So it should be from variety of devices. Unfortunately, it is challenging task to collect a variety of images in medical imaging field, which can be representative to the problem. So we have adopted a synthetic data which we have created by developing algorithm is exactly similar to the real ultrasound acquisition system. So now I'll be playing a clip for you which will demonstrate how we have created a synthetic images which is based on a real ultrasound acquisition model, and this is just a one single clip to just to make you understand how the synthetic data has been created. And this synthetic image contains exactly similar artifacts, textures, feature of a real ultrasound images. So if this scan we call B scan in ultrasound, we have also created an algorithm which also able to create for linear scans. So we have algorithm which create for both kinds of image, linear scan and B scans. So if you will see here in the right side image, you will find we are having pretty much similar color tone, which is grayish and blackish, and then we have a features and the texture and then artifacts similar to the real ultrasound images. But in order to evaluate the quality of these images which we have created using our algorithm, we have to adopt some techniques which can validate for us, yes, the whatever the synthetic images coming out of from the synthetic system or from algorithm is similar to the real ultrasound images. So for that, we have adopted 21 statistical features and some very high level features to analyze to analyze the synthetic data feature, and the same techniques has been used to analyze the real ultrasound image feature so that we can compare. So these techniques help us to build a confidence, yes, that both synthetic and real ultrasound images sharing same features and which are good for problem in hand. So here is another example of data-centric modeling aspect, which is a feature engineering and transferring of SME knowledge. So this is a biopsy slide. This is a big biopsy slide at your left side, and then you will be finding some tiles at the right side. So these biopsy slides are pretty much big. One slide was of size like 2 gigs. We have pretty much good amount of biopsy slides through which we are able to create as much as styles we want. The major challenge here, transferring pathologist expertise knowledge and create tiles based on their knowledge from biopsy slide and it score each tiles against them. Basically how pathologists evaluate, analyze biopsy slide to find benign and malignancy. Same level of information needs to be transferred into the modeling. So, another piece of work in present organization and presently involved, we are building forecasting model for various services at various level for effective resource allocation. In order to attain an optimum level of forecasting accuracy, which can help business making a strategic decision timely. We are closely trying to work with SMEs so that same knowledge can be transferred from data collection to model building phase. Adding and deleting data based on problem in hand and based on model performance, data repairing, and overall trying to improve the data quality and finding the best feature which has the ability to produce a desired level of forecasting. In this graph, you are seeing a blue line, which is an actual for us, and the orange is a forecasting, and other tools are projected. None of us able to give an accurate short-term forecasting. For few services, it is providing desired results, but we want them for all. So crucial step is that what we are missing at data level. When all the data is coming from the same process, why we are unable to obtain a similar accuracy for all the services or data doesn't have a ability to do a forecasting. So there is a various questions for us which we are unfolding at the moment to obtain a same level of accuracy, same level of forecasting for all the services. So data repairing. So there are various aspects in the data repairing or various areas in the data repairing which can help us to improve the overall data quality. Data quality can be defined as the fitness of data to fulfill the business requirement. It is achieved through people, technology, and process. Making sure data consistency when data coming from different database or data combining from different tables, different database. Without proper data quality management in place, even some error in data potentially lead us making inefficient decision. Even it will make us difficult to explain why model is behaving this way. Data quality and data cleaning are always linked together. It is crucial to make sure quality and cleaning properly done based on the problem in hand. And data quality metrics should be properly designed and well communicated with data science team. So MLOps, machine learning in operation. So here I would like to highlight four aspects of data quality dimension in MLOps workflow. ML quality optimization for models. Here we are considering various factors of data versioning. Here we are checking adding data hurt model performance or not, important features, non-important features, finding best parameter on best data version we have, testing to prevent overfitting, and the most important are data drift and concept drift. If data is not static or partially volatile or highly volatile, we know data changing frequency is high, then we should place some metrics which can alert us when model performance starts degrading so that we can retrain model on new data. Before retraining, do perform data quality analysis. Just do not blindly trust models. So here I would like to give some insight how data itself debt in ML. So here we have been seeing various blocks. Some are very big blocks, some are very small blocks, some are very tiny blocks. So the main idea behind depicting these blocks in the figure is to show that in real world ML system, only a small fraction of ML code is involved. And the surrounding infrastructure is vast, complex, and time consuming to build. To build a successful ML application, we need to invest resources in various components. So far, from data-centric AI standpoint, data itself is the largest investment. And data itself is a great and valuable product. When I say data itself is a great and valuable product, if we are able to create a data that is able to fulfill a business requirement, then we can easily develop a lot of successful ML solution on top of data. Let's see one scenario. Here I have presented one scenario just to make you understand that how data is a debt in machine learning. So in order to develop a verbal movie recommendation system, or I should say verbal movie recommendation model to help user to pick a movie for a Friday evening or a weekend evening. So what does that mean? We are developing a system which recognize user's voice in order to pick a movie for weekend evening. So ability and behavior of our model will be defined primarily by what data we feed to the model. The main question comes here. Why spending so much time, effort, energy, and computation resources on so many billions of training data, which might not generate desired results? This scenario is just to give you a perspective. So with that, I would like to conclude my presentation for today. Data itself is product. We need to put most of our efforts primary data level activities. Data in its quality management is more important than machine learning. Machine learning is becoming a new software. And of course, AI and bias problem cannot be completely solved through the technical solution. It's people, technology, and processes. Thank you so much for attending my presentation. Feel free to contact me for any discussion around today's topic or some other topic in the same area. I'll be happy to discuss. Thank you so much. Have a good day.